Why did you laugh when I was starting? What's going on? I guess we're gonna have to wait a second to start this video. Go ahead, get it out of your system. What's going on?
Okay, are you good? Is it all the way tight?
Hi, I'm Colin with Clean Air Heating and Cooling, and the purpose of this video today is to talk about ductless heat pumps. So the first few minutes of this video, I want to talk very briefly about the installation of the units, what goes during that process, the penetrations we have to make through walls of homes so that we can run the line sets, placement of the outdoor unit, placement of the indoor unit, and a few really common questions that clients ask. In the second section of the video, I'm going to go into more details about the installation, about the noise levels, the efficiencies, and all the different characteristics that come with these units and what possibilities there are to maximize the efficiency of these units in your home. Now, if you're already looking for a ductless heat pump, you might have already done a lot of research and you might already know a lot about them. But in case you don't, I'll just really briefly tell you what they are and what they do in very high-level terms. So this is the outdoor unit of a heat pump system, and there is its counterpart inside, which is on the wall, and that is the indoor unit of the heat pump. These heat pumps are connected with two pieces of copper here. There are two copper lines and then some wiring. And then there is also a condensation drain that we're going to show you how it gets installed here in a minute. These units in the wintertime absorb heat energy from the outside air and passes that energy through these copper lines into the indoor unit, which releases that heat energy into your indoor air. So that's why it's called a heat pump. It transfers heat from the outdoor to the indoors. In the summertime, they can work as an air conditioner, and they absorb heat energy from your inside air, and it releases that heat energy outside at the outdoor unit. So it reverses the cycle. A lot of people ask us, can I just get a heat pump and not get an air conditioner because I don't need cooling in my home, I just need heating. So the truth is most heat pumps, actually all heat pumps, do both heating and cooling. There's no heat pump on the market that only does heating. But on the other hand, if you just want an air conditioner in your home, you can get an air conditioner only and not a heat pump that will just cool your house and not heat your house, and you'll have to rely for another source of heat for your heating in the house. One last point about what heat pumps are. A lot of clients ask, why do I need a heat pump and how are these compared to other types of heating? So the heat pumps nowadays, especially the Mitsubishi Hyperheat model, is one of the most efficient units out there, and many of these models are actually the most efficient in their class in terms of their heating capacity at low ambient outdoor temperatures, and in terms of their capacity and energy consumption and the amount of heat you get into your home based on a certain amount of kilowatt usage. So these units will almost always pay for themselves in just a few short years when you transfer from something like propane or electric, and they are just amazing in a lot of ways, but especially the efficiency is a big selling point for them. Later in the video, we can talk about when you should choose a heat pump and about the pros and cons of ductless heat pumps versus other heating types. But for now, let's go into a few basics about the installation that are very common questions that our clients asked. Since we are outside, I'm going to talk about the placement of the outdoor unit. A lot of clients want to know where can this be mounted. So really briefly, I'm going to go through all of the possible locations for the unit. The most common is what you see here. It is mounted on the ground, and in most cases there's going to be a flower bed, or there's going to be a garden bed or lawn or a rock bed already. And that's the most common placement, behind the house, next to the garage, something like that. And each house is different, and the landscaping around each house is a little bit different. So we can work with most locations that your home may have around it as a possibility for the placement. In this case, as you can see, we brought several buckets of crushed gravel so that we compacted that down to give the unit a stable base. And then the other thing that we brought is a pre-poured cement pad. And this has some foam built into it so that it absorbs vibration from the unit, which, by the way, this unit is extremely quiet and the vibrations are very minimal and really not noticeable by most people. But this is just an added benefit of making sure the unit is as quiet as possible. Next, what we have is a couple risers here, and the reason these are very important for a heat pump, in the wintertime, when this unit goes into defrost mode, it melts the ice on the coil, and that ice obviously becomes water and pours out of the bottom of the unit. If you see this with your heat pump, that is normal. And all that water gets poured in this area. If there's snow accumulation or it's just a long winter and a lot of water gets poured out and it's under freezing temperatures for several days in a row, that water will build up into ice. And if there is no gap between the bottom of the unit and the ground or the pad, that ice can actually build up inside of the unit, crushing the coil. Some of the watchouts with this type of placement, as you can see, there is a roof right here and there is an awning that's coming out. The soffit is probably 2 feet wide and it's totally beyond the point of the unit. And the unit is around 10 to 12 inches wide, sometimes up to 14 inches wide, depending on the model. And we typically like to have about 6 inches of space between the unit and the wall so that the airflow can go behind the unit and get pulled out by the fan. And also air goes in the unit from the side as well. This corner of the unit has the controls, the compressor, and all the wiring and the piping connections, and there's no airflow from this side. One of the things to keep in mind as you're looking around your house for possible locations, as you see me standing here, a service technician, when we come out to service this unit, this is the point of access and a little bit in the front of the unit as well as the top of the unit. So ideally we want to have 36 inches of access right here, which is about this much. And in the back, like I said, 6 inches. In the front of the unit, it varies by model, and we can look in the spec sheet to find that out. But in front of the unit, we want to see around 3 to 4 feet ideally. There are some specifications where you can actually have less than that. And then on the other side of the unit is around 12 inches in most cases. If you have any kind of shrubs or greenery growing around the unit, these things grow slowly sometimes and sometimes quite aggressively, but you don't see them grow. But from one year to the next, when we come out to service these units, a lot of times we find that the shrubs have grown branches into the unit, or that 36-inch gap that's necessary for service has become 1 foot or less, and now we just don't have access. And we don't want to hack into your beautiful bushes to get into the unit. So just keep in mind serviceability down the road. Some people like to hide these units behind bushes and plant things in front of them. Again, the same challenge there is with these things overgrowing, and you may not notice that's happening at times, and then the unit can't breathe as well as it should, and it will affect its efficiency. And I'll give you one other watch out for these units. Sometimes the eaves are not this far out from the roof, and you can have snow accumulations and maybe 1 foot at times, and then the warm weather comes and all that snow comes down in sheets. Sometimes it's ice and snow, or just the weight of the snow. For the most part, these units don't really get damaged too much by that, but if you have a heavy sheet of ice coming down on these units, it can cause some damage. So for the most part, it's just a bit of maintenance for you to go around and make sure that there's no large snow accumulations, and try to stay ahead of, encouraging that ice and snow to come off your house in a controlled manner. Some people like to build little roofs over these units. Again, that's okay as long as it doesn't impede our access to the unit, and we would like to have at least 2 feet over the unit so we can remove this lid and access the control board, the fan, and other components inside of the unit for cleaning and maintenance and servicing and diagnosis. The other option is to set these units in a carport, in a driveway, on a walkway that's concrete or pavers. And we typically try to stay away from those types of installations because, like I said earlier, when the unit goes into defrost and all that ice gets melted off the coil, that can become ice onto your walkway, driveway. So we'd like to avoid that tripping hazard potentially, or otherwise you will have to find a way to mitigate that ice from forming onto your driveway. But in some locations where there's no other possibilities, that may be the only way to go. It's just not the most ideal. The other thing I can talk about is these units, we install them on the wall quite a few times, and that's usually when there's no room on the ground, there's too much going on, or there's not enough space or clearance between the home and the neighbor's home, and sometimes we have to mount them on the wall. We use a very sturdy bracket that's usually rated up to about 300 or 400 pounds, and these units weigh anywhere from about 80 pounds to about 200 pounds. So these brackets are extremely solid, but they do rely on a strong framing behind the wall. So the house has to be built fairly well for that to work. And we install really long lag bolts and screws to make sure everything is mounted solid. We use the proper mounting feet so that they absorb some of the vibrations and noise. But when the unit is mounted on the wall, you're going to have way more vibration than when it's mounted on the ground. That being said, with the unit mounted on the ground, some of the vibration will be transferred through the piping itself. So as the piping carries the refrigerant through the house and the piping is secured with clamps up against the wall, it will pass some of the vibration into the wall, and there is no real way to get away from that. Obviously there is foam insulation here, which is a thermal insulator. It also absorbs some of the vibration, but in the end, if you're really sensitive to noises, you may hear some of that. But I would say almost 100% of the time that's not a complaint, but rarely that can become an issue. One more location that we've installed these units, and it has been a real good fit for a lot of homes, is on the back deck, front deck, deck wrapped around the house. If you have any kind of deck that is a suitable location for this unit, we would love to explore that and help you decide if that's the best location for you. A real common question that clients have is the size of the outdoor unit. I would say this is probably in the middle in terms of average. Some units are a lot shorter than this, and some are actually about this tall and a little bit wider. So I would say this is probably the size that you can most commonly expect, which is about 32 inches or so. But some of them are up to about 42 to 44 inches wide and anywhere up to about 48 inches tall. So depending on the size of your home and what the home needs, the unit will most likely be proportionately sized to meet the demands of the house. Occasionally, we've encountered where there's one spot that it can be mounted outside, like one single place because nothing else would be feasible, and then there is a window, a very large window, where you can see the unit from the inside. So that's another thing to think about. Will you see the unit from the inside? Will that bother you? Most people don't care, but it's something to consider. Speaking of possible locations for the indoor unit, in some homes people will have two stories, the basement and the main floor, or the basement, main floor and top floor, and they would like one unit per floor. And the reason that's a real good benefit is each floor will have its own temperature, and heat rises in all seasons, and you may have a basement that's really cold, a fairly mild temperate main floor, and an extremely hot upstairs. So with a ducted system or other forms of heating, the heat gets trapped upstairs and you're uncomfortable downstairs. So some people will put one unit per floor to mitigate those differences, and each unit will operate at the appropriate level to maintain that floor at the right temperature. So in those situations, we've seen homes where it's 70 downstairs, 70 in the basement, 70 upstairs, and everything looks great. When a unit is installed in the basement, oftentimes it's all concrete walls and there is no pony wall or any wooded structure that we can drill through. So in really extreme cases, and I think I've encountered it once or twice in my 13 years of doing this, you will have to bore through the concrete, which is really something we want to stay away from if at all possible. So, the best solution in that case is to actually install the unit on the wall, run the line set exposed in the spirit channel and the line set conduit that you see outside typically, run it exposed on the wall inside, and then usually go up into a ceiling and then go out through the rim joist, which is wood, to have the penetration going to the outside, and from there the line set gets ran to the outdoor unit. So that's usually the way that's done. Obviously in that situation, besides the actual wall mount unit, which is about 28 to about 36 inches wide depending on the model and size, it's about 12 inches tall and it's about 8 inches thick. So besides that, you're going to have this 4-inch thick plastic speedy channel line set going up into the ceiling, or just terminate somewhere on the edge of the wall. So some people like that and they're okay with it depending on the decorations and the layout of the house, and some people are absolutely not okay with that because it doesn't fit in with what they have going on. So I wanted to share that with you so that you guys, depending on the situation you're in and the layout of your house and your final desired product, you may have to consider those possibilities. Now the other thing to keep in mind is that most of the outdoor units look the same outside, but inside, the most common indoor unit will be a wall mount, which is that shape that I told you, a rectangle that's about 30 inches wide or so. There is also a few other models that have been available for a long time, just not as common, and those are ceiling cassettes. A ceiling cassette typically is about 2 feet by 2 feet, and it's about 1 foot tall, and these things go in the ceiling, and it would line up between the trusses, which are 2 feet apart. So it's actually 22 and 7/16 between the trusses. If we can have that kind of clearance between trusses, we can install a unit recessed in the ceiling with only about a 1/2 inch or a 1 inch register that's showing on the ceiling. So it's very low profile and it's not as visible, and it blows heat or cooling into 4 directions, and then the air gets pulled in through the middle. And they have filters on them just as well that have to be maintained. So in some homes, these are really good solutions. And in some homes, we cannot fit that between the trusses, either because the trusses are not aligning perfectly in that location, or somehow they are bowed, or they have the different components there that just don't give us the clearance. So we have to use a single direction ceiling cassette, and they come anywhere from about 12 to 14 inches wide, and they're about 42 inches long, and again about 1 foot tall. And those can fit into areas where the truss spacing is much smaller, but these units just blow into one direction in the room. So a lot of times we mount those in the ceiling on the edge of the room, so it can, just cover the whole room, or a living space that may be kitchen, living room, dining room, hallway, things like that. And if you have a home that maybe you have an open space, but then you have a hallway and a bunch of rooms on the different sides, a lot of people choose just to do one unit in the main part of the house that will blow down the hallway and condition the space surrounding the unit, and also push some heat or cooling into the back of the house. And up to maybe 1,400 square feet, 1,600 square feet, depending on the layout of the house and how open it is, you may get away with that. Some people like to do a second unit in their master bedroom, and some people just put one unit in every single room, so they're happy in any part of their house at all times. So the other thing that some people really like to do, and this is actually a real cool solution, they make these models that are either silver, black, or white, and these are wall-mounted units, and they only work with multi-zone outdoor units. So that means you have to have at least 2 or more connected to the same system. At this moment in 2021, they're not available on one-to-one models, but hopefully soon they will become available. The beauty is all of these indoor units are paintable, so any automotive paint shop or anything like that that's good quality can do that for you and put almost any color on it. And it can also be wrapped with vinyl, so a good high quality vinyl shop can do that for you, and it's not really that expensive. And you can even use, I've seen people do this with a log cabin, where they take a picture of the wall, they print that on vinyl, and they apply the vinyl to the unit, so it's really easy to blend in, and you don't really notice unless you're specifically looking for it. So there's a lot of creative ways to do it after the installation. And then a couple more options would be a wall-mounted but close to the floor unit. And these units are again about 27 to 32 inches wide. They're about 24 to 27 inches tall. They're about 7 inches thick, and they look like some of those European radiators that are close to the floor. Some people like to hide those behind the couch because they don't see them. The only drawback with that, the unit blows out the top and pulls in the air on the front, and sometimes those units actually even blow at the bottom depending on the model. So hiding it behind the couch with no airflow really restricts its ability to condition the room correctly. So keep that in mind as you're thinking through all these options, or if you're looking at a catalog or on a website that has all these different possibilities. I know it can be a bit chaotic trying to put all this information and make sense of it all, but I'm hoping that this helps you understand the real life scenarios and how this impacts people's comfort after the fact. So if we can help you avoid any mistakes in the design phase, then that's the goal of this video, so that you guys know as much as possible ahead of time to make that design phase as smooth as possible, and know the pros and cons of all of those choices. And then I'll also mention 2 more units that are also actually fairly common nowadays. One of them is called a slim duct unit. And if you've ever been in a hotel, which many of us have, when you enter the hotel room, the ceiling is really low, and right above the ceiling there's a very slim unit. It's probably 8 to 10 inches tall, maybe a couple of feet wide, a couple of feet long. Some of them are wider, and you just have this one big register blowing on you into the room. And that's what those things are. They're just like a conversion from a commercial space into a home. And in homes with really shallow attics or crawl spaces, we can install these units, and they're designed to have ductwork attached to them, and then we can run those ducts to a few different rooms that are adjacent. So a lot of bedrooms, bathrooms, things like that, or a master suite, we can use a unit like that and condition a small amount of space. But we've done larger homes with them too, and we've been able to condition up to 2,000 square feet, and it just depends on the characteristics of the house and the BTU load calculations. But it's a really good, useful tool. They are pretty labor intensive. They require ductwork, so a lot more work. But the beauty with that is concealed, is out of your way, typically in an attic or a crawl space. We just have to mitigate for the condensation drain, and we have to put traps to catch all the condensation if there's a leak. So those are things to think about, but they complicate the installation a little bit, drive up the cost based on labor hours and materials necessary. But then the final product, you just have the registers on the wall like you probably did with your old furnace. So you may not know that you have this high-end, very efficient heating and cooling system up in the attic, and it looks just like an old furnace, putting its air out through the registers. So that may be a good fit for you. And then lastly, I'll talk about the multi-position air handler. And Mitsubishi makes one of the best. There's other brands out there that make a decent one. I would say Mitsubishi potentially is the best. That's my opinion nowadays based on what I've worked on. And they are really, really good about giving you this product that's very well insulated, very high quality motors, very high quality products. They're very reliable. They resist surges quite well, although they're not meant to, but they just have a lot of built-in features to make them strong. You should still have a surge protector, but they're just an awesome device. They're very quiet, they're very variable speed, and they work really well in a lot of homes where you already have ductwork and you're trying to go away from fossil fuels and do something electric. So you can get a heat pump like this, install one of those units that ties in with your ductwork, get those ducts cleaned, sealed, and updated, get an air purifier, air scrubber, whatever you need to treat the air so it's clean and healthy to breathe. And these air handler systems just fit right in with that. The one thing we have to do is run power, 240 volt from your panel to that air handler, and that's if you want electric backup. If you just want to rely on the outdoor unit to provide all of the heat to that, then all you have to do is basically just run power from the outdoor unit to the indoor unit, and you don't have to run a dedicated power to it. And then you just have to run the 240 volt from the panel to the outdoor unit. So I know I've kind of blown through all of those choices real fast, so you may have to pause and go back and re-listen, or just ask me if you have any questions or you want me to elaborate on any of those points. But those are the possible indoor units connected to the outdoor unit. And next I'm going to talk about why someone would choose a heat pump. Like I mentioned before, a lot of people are trying to get away from high-cost propane bills, high-cost electric bills, or the use of natural gas, and they will go to the electric heat pumps. And historically, I'm talking about 30 years ago, 40 years ago, when heat pumps were not as common, the quality of the heat pumps and the efficiency of the heat pumps was not that great. So the savings was minimal, and the impact on reducing the energy usage was very minimal. In the last few years, especially with the hyperheat model, it's an amazing product. So basically, you can think in terms of 2 to 3, sometimes 4 times, sometimes 5 times reduction in energy consumption. So it's a real good way to go. One caution I'd give you is look at where your power source is coming from. If it's solar or some sort of clean energy, that's absolutely amazing. An efficient unit like this that's electric will just help you utilize that even more. But if the fuel source is coal or other sources and that's not as clean, it kind of defeats the purpose. At that point, it just reduces the consumption. It's actually still a good thing, just not as impactful as if the energy source was clean. But they use much less power than an electric furnace, and so their impact on your electrical panel and the power available to your house is fairly minimal, and probably the least compared to most other systems available. So it's really one of the best systems to use compared to anything else out there. Electric furnaces, propane furnaces, gas furnaces, boilers, geothermal even. We've got a lot of clients asking about that because historically geothermal heat pumps have been the most efficient systems because the ground source heat is even throughout the year at 6 feet and below. So that was a really go-to for energy efficiency, but the upfront cost of installation is exorbitant, so it's rarely justified. So since the new heat pumps have become so efficient, you can really have extremely high efficiency, almost at an equal level with geothermal heat pumps. I also want to bring up one important fact that we get a lot of calls from our clients about, and this is when the unit goes into defrost, the operation cycle changes slightly and the fan stops running, but the unit keeps running. So when homeowners observe these units when they are new and they get used to their mode of operation, they get a little bit alarmed that the fan has stopped running, the unit is still working, and something must be wrong. So the reason that's happening is the unit goes into defrost mode, the coil will get very warm, and if it's cold outside, the unit stops the fan operation so that the coil can get warm enough to melt all the ice. So that's perfectly normal, so don't get alarmed if you see that. The other thing that we get calls about is the coil, which on the back of the unit and the side of the unit, the coil will get frost on it. Usually it looks white, like white frost, and you should only have a small layer of that. That is totally normal. It can operate like that for several minutes before the sensors time out and they realize, okay, we have to defrost this. And then the defrost cycle starts, and it should stay in the defrost cycle anywhere from 5 to about 15 minutes and go back into the heating cycle. When people see the frost, they get a little bit alarmed. So again, don't get alarmed if that frost gets handled by the unit on a regular basis. When you should be a little bit alarmed is when you have half an inch to an inch of ice on the back of the unit and the defrost cycle is not able to defrost that all the way. When the defrost cycle ends and the fan starts to come back on, because the coil has been hot, it starts blowing out a cloud of steam and vapor, and people sometimes freak out about that because they're afraid the unit is smoking, burning, something electrical happening inside, or sometimes they think it's a refrigerant leak, which would look the same if the refrigeration lines would have a leak in them. So again, if it's during the winter time, in the cold months of the year, if that's happening, don't be afraid, expect that to happen. During the defrost time, there will be a lot of hissing and popping and quite a few different noises that are not commonly heard throughout the year. Again, that is also normal up to a point. So feel free to explore that on your own and observe that. If anything is outside of the scope of what I've mentioned here, there's probably a problem and you might want a technician to come look at that. As far as the maintenance for the indoor unit, for the most part, as a homeowner, the only thing you really have to worry is actually two things. One would be to pull out the filters, open the door, pull out the filters, wash them or spray them with a cleaning solution, rinse them with water, let them dry and put them back in, close the door, and that's all you have to do. In a lot of homes, that's required about once a month. In some homes, it can go a little bit longer, but at least every 3 months you should do that. Even though they don't look too dirty, there are very tiny particles that collect on them, and that's what should be done. Secondly, the thing that you need to keep in mind, these units have to be serviced by a qualified technician at least once a year to maintain the warranties, to maintain the efficient operation of the unit, and prevent problems that are preventable during the annual maintenance. So typically, we go and check the coils, the fan, the amperage draws, the temperature, and we check the entire system indoor and out and how they operate together and the pressures, and we go through a lot of points on the checklist to make sure everything is running correctly. This is what's required by the manufacturer to ensure this system operates as long as possible, and you can extend the life of the system by doing this correctly and make sure that it lasts as long as it's expected to last. So the next point I want to make is about keeping the unit clean. Homeowners ask us, what do I have to do to keep this unit clean? So I think the few things that are really important for you to keep in mind, at least in the Pacific Northwest, the main culprits for plugging up the unit are cottonwood, which is a very specific time in the summer that's happening, leaves in the fall, and snow, if we have snow accumulation. There's one other item that can happen, and that's based on the placement of the unit. If there is a dryer vent outlet really close by, that lint can be sucked into the unit because the unit is operating, pulling air from behind, and that lint is getting sucked into that low air pressure zone and pulled into the unit, and it plugs up the coil. So for the most part, we try to stay away from that. Like in this location, we are about 15 feet away from the dryer vent, and we try to be as far away as we can, but 10 to 15 feet away is usually pretty good. Again, in some locations, the only place was really close to a dryer vent and there's no other place, or these homeowners would not get a unit. So sometimes you kind of have to make do, but be aware of those possibilities, and it's something that you have to keep an eye on the back of the unit at least once a month, or once every 2 months. Come take a look. If it's dirty, you can use a very cheap, light bristle paintbrush and just brush those things off. You can use a garden hose with a nozzle and just rinse it off. No pressure washer, no chemicals, and that's pretty much all you have to do to keep it clean. And in the wintertime when there is snow, my experience has been that if it's really windy and there's the drafts of snow, the wind actually blows air around the unit and the snow doesn't really accumulate in those spots, so it doesn't really block the unit. That's been my experience. But again, keep an eye out during that time. Try to keep an area clear. If there are drafts of, or drifts, I should say, drifts of snow in front of the unit, try to shovel those things out so that there's some airflow around the unit. Again, maintaining those clearances of 3 feet on the side, if you can, 2 to 3 feet on the front and at least 1 foot on the other side. When it comes to the coil cleaning, we usually come out on an annual basis and service the unit for you. So typically, all the things that I've mentioned you can do. Anything in addition to that, there are some chemical cleanings that we can do and some other things that we've been trained by the factory to do it correctly so we don't damage the unit. And these units come with a 12-year warranty, which is phenomenal for a mechanical product with moving parts and electronics. That's a really, really robust warranty. So the only thing that you really have to keep in mind is buy it from a contractor that does a good job designing the system correctly for the house and installs it correctly and maintains it correctly. So if you do those 3 things well, you should really get probably 12, 15 or more years out of the unit, and 12 years on parts and sometimes even on labor. Warranty is really good. Briefly, I want to talk about the cycle times of the units, because some people buy these units, they keep them really comfortable in the summer and winter and they love them. And some people keep a closer eye to see how they operate to make sure everything is working well. And occasionally there are some questions about, why is my unit running so long, or why is it cycling on and off? So these are all legitimate concerns. And briefly, I want to talk to you about the fact that these units are variable speed and variable capacity. So the compressor starts at a very low RPM, basically 0 RPM, and it slowly starts turning and speeds up and goes faster and faster. That keeps a very small amount of electrical power draw on your grid, and that minimizes the electrical consumption, and your lights won't dim in the house, and it keeps it quieter. It builds up the pressures up to about 30% or 35% capacity, and that's where the system operates. And it'll try to stay there for as long as possible to match its ability to either heat your house or cool your house given the conditions at that moment. At times it has to ramp up or ramp back down, but the unit is designed to try to stay on forever. And that's good, because we have a predictable amount of lifespan in these units, and the longer they operate without cycling on and off, the healthier they are and the fewer breakdowns and the less wear and tear on the equipment. So if you see it short cycling every few minutes, usually that tells me there's a problem either in the design, or something is breaking on the unit, or something was done wrong with the installation. So you should not see a lot of short cycling of the equipment, but typically you want to see 10, 20, 30, 40, 50 minutes per hour of operation time, and that means the unit is matching the needs of the house most of the time really well. So a big topic of discussion when designing these systems and talking to our clients is the location of the indoor unit, and how are we going to run the line sets, how are we going to get from inside to the outside, and the penetration location. So typically the best place to have a hole is behind the actual indoor unit, so that the indoor unit conceals that hole and the finished product looks really nice and clean. So that's the most ideal. Sometimes that's not possible, so I will show you later what can be done and show you some pictures of what we've done before to make it look as decent as possible and try to blend in with the decor of the house so that everything looks clean when we are done. So here we are above a window. The toughest part to drill is above a window, because most windows have an actual beam across. In this case, this is older construction, a little bit not standard, I would say. And so there are some 2x6 beams here, and there's some sheeting, and then there's some other stuff in there, but there is no actual beam, which is what you should see above a window. So this actually allowed us to drill right above the window, but this is almost never possible. So what I'm showing you here is an anomaly, unless you have a very old home or something is really not up to code. So that being said, most times the indoor unit will either have to be mounted indoors to the side of the window, either one side or the other, or above the window, but then this line set will have to be mounted on the wall, surface mounted inside of the house to the side of the window, and then we have a penetration coming out where it doesn't go through the beam. So in this case there was no beam, so that was not a concern. Next, what I want to point out is the pipes that are here. So the white line that you see is the condensation line, and in the air conditioning mode, the indoor unit collects heat from your house air and it collects moisture from the house air. This makes the air indoors a lot more comfortable in the summertime, and that moisture gets collected into the bottom of the unit in the drain pan, and from the drain pan it comes in through this line and we drain it outside all the way down into the flower bed or a suitable location outside. The next two lines are the suction and discharge lines for the unit, and these ones have a low pressure and a high pressure, and this is what carries the refrigerant and does all the magic in your house. And so these are two connections that whenever possible we like to have these outside so they are easily accessible. If it ever develops leaks over time, we have a lot of access to torque them down to the right tension and make sure that the leaks are solved. If the flares are done correctly and they're clean and it's torqued correctly from the beginning, then you should expect not to have any leaks at all. A really common question clients ask us, how often do I have to top off my unit with refrigerant or Freon as they call it? The answer is never. If you ever have to top it off with refrigerant or Freon, it means there is a leak, and there should be no leaks. So for the life of the unit, it should contain the refrigerant it comes with and the refrigerant that we add to it based on each job what it's required, and you should never have to top it off. The reason people are used to topping it off is back in the day, before the regulations with wasting refrigerant were there, people would just top things off. And a lot of technicians were not really trained properly, so they would just sell refrigerant to people and go there annually and top it off rather than fixing the problem. So that's really not accepted nowadays. It's not really common practice anymore. And so we have to do our job correctly from the beginning and not cause those continual callbacks to top off the system with refrigerant. If you ever have a leak, if it's a very minimal amount that has been lost, maybe we can top it off one time, but typically we have to actually find the leak and solve the problem and then fill the system with refrigerant again. Next, I want to talk about the copper lines. In the air conditioning mode, these copper lines get some frost and some moisture on them if they're not covered correctly. So the reason there is insulation on them is not to waste that energy that is producing, and also to reduce the chances of this condensation dripping onto your drywall, inside the wall, or in any other conditioned space. The other impact with ductless heat pumps, you're converting energy from the air into the refrigerant and back into the air inside. So there's only a couple conversions of energy or heat exchange. With the geothermal, you're going from the ground into the glycol or water that's in the ground loop. From that goes on the high side of the heat pump into the, actually on the low side of the heat pump into the evaporator, and from there into the condenser, and from there back into the water, and from that water back into your air. So there's several exchanges which might reduce the efficiency slightly, and geothermal heat pumps historically haven't been as efficient as some of the Mitsubishi Hyperheats have been. So you can do your own research on the specs, but just to kind of answer that topic about geothermal, it's generally not a better way to go compared to a ductless heat pump. So like I said at the beginning of this video, the reason I put this video together is to give you guys an idea of what's available with heat pumps, what they are. I know maybe for some of you that know a lot about these, some of this information was unnecessary and too detailed, and for some of you maybe I went too fast and I wasn't detailed enough or didn't explain it enough. So I just wanted to give you a starting point, or maybe hopefully this video helps you clarify some of the knowledge that you've heard from different sources. And I know there's local contractors in your market, and there's online resources, some credible, some not, so it's really hard to know who to trust. But as a service technician, I do design work, I do installation, I do service work. I've got all the certifications and training required, electrical, EPA through the manufacturers, by the state, whatever's required. So You can trust me, obviously. I just want to make this an informational video and bring you some value. But there's so much more that can be talked about, and those answers may change from house to house based on the specifics of that house, and also from family to family based on their requirements. Everything from financial, what makes sense for them in terms of purchasing a piece of equipment, as well as the comfort and the air quality in their home. So there's a lot of versatility and options and opportunities with this system. I think the biggest thing you want to look for is someone who has your best interest in mind, that understands the equipment and what's possible, and tries to really find the one unique system that perfectly matches your needs, and that is possible because the options are endless right now. The reason I spend the time to explain these things is because in my 13 years of doing this, these seem to become repetitive questions that homeowners don't really deal with very often. Most of us buy a system like this every 15 years or once in a lifetime, or maybe never till now. So being really up to speed with the technology that's changing so rapidly is really hard for most homeowners. So I just want to put this out there so that people can really get an opinion from the hands-on and the in-the-field point of view on how things go together, and pulling from my vast experience with homeowners as everything from complaints, compliments, success stories, and all that. I just want to share this information with you. And like our motto says, your comfort is our passion. This is truly down to how we feel about this, and we just want to help you get comfortable in your home, achieve your goals, and enjoy the life indoors. If you want any more information in addition to all this, I'm more than happy to help you out, have a conversation, shoot me a text, call me, comment, do whatever you want to get in touch, and I'll be more than happy to help you out. Number here is 360-398-9400.